Our goal in this video is to be going to In this video, we're going to discuss how do we keep track of what state we're in. Now, the difficulty here is that at each time step, we're going to make a random jump. And somehow we need to keep track of that idea that our location is actually kind of probabilistic. And so what we're going to do is we're going to start by introducing a vector, u of n. Sometimes you'll see me write it as x of k, but it's more or less the same idea. What this vector is going to contain is the probability of being in any particular state. And it's the probability of being in a particular state at the time step n. Okay, so let's say we're beginning our night of going out and we start in state 1. Okay, so one way we could write that is we could say, well, u at time step 0 is equal to 1, 0, 0. And what this tells us is that we are 100% positive that we are in state 1 because that's where I said we started. Right? We have 0 and 0 because if we're in state 1, then we can't possibly be in state 2 or state 3. So the next question might be, well, let's say after state 1, where might we be? So what we want to calculate now is u at time step 1. Okay. And we're going to logic this out a little bit, and we'll see that this u vector and this p matrix, we can combine them together to actually learn something and to make some fun equations. Okay, so if we started out at state 1, where might we be one time step later? Well, with 0.2 probability, we're going to stay in state 1. And so that tells us that when we look at u, this probability of where we are at time step 1, we're going to have 0.2 right there. Okay. Now, there's a 30% chance that we go over to state 2. And finally, there's a 50% chance that we end up at state 3. Okay. Now, the big question becomes, how do we calculate where we are at time step 2? And more generally, at time step n. Okay. Well, it ends up that we can just use our matrix and our state variable in order to do that calculation. The way we do that is we say, well, u of 1 at time step 1, if we actually look at what's happening here, it's equal to the transition of p times u of 0. Okay, so let's see what's happening. So one way that you can think about it is you can see that when we take the transition of this matrix, I'll write it down over here, we end up with 0.2, 0.2, 0.5, 0.3, 0.70, and finally 0.5, 0.1, 0.5. Okay. And so what we're doing is we're going to multiply just like before in matrix algebra, row times column, row times column, row times column, right? And this matrix is basically going to tell us how the probability flows from step to step. And so what we can see here is actually the way we get 0.2, 0.3, and 0.5 is we multiply the first row times our vector. So we end up with just 0.2 times 0.1. That gives us our first value, right? We take our second row, right, and we multiply it times u0. So we pull out the 0.3. And finally, we take out our third row and we multiply it times our vector, pulling out 0.5. So the question becomes, well, what happens if this actually worked out? What about for time step 2? And for time step 2, what we're going to do is we're going to say, well, I'm going to multiply our probability transition matrix times the vector u, which again, remember, stores where we think we are, or what the probability of where we might be at that time step. Okay. So let's go ahead and we can write out this matrix and hopefully do the multiplication. So we have 0.2, 0.3, and 0.5, which we are able to just calculate by hand. But now things are a little bit more difficult. Because what's going to happen is we're going to have 0.2 probability that is going to get spread around according to these transition probabilities. And then we're going to have this 0.3 probability that we're in state 2. And it's going to get spread around according to that row. And finally, with 0.5 probability at time step 1, we're in state 3. But we know in state 2, 0.5 of that is going to stay here. 0.5 is going to move. And so what we're going to do is we're going to see how each of these probabilities end up flowing throughout this matrix in the next time step. Okay, so let's go ahead and do that. So we have the first equation, but what I'm going to tell you is this actually holds for each step. All right, so we can fill in this matrix. And again, it's just the p-transition matrix that we wrote before, but transposed. So now what I'm going to do is go through and do this multiplication. I'm not very good at doing this by hand, or at least in my mind, but hopefully we can sort of figure it out. So we have 2, 2, 2, 6, 5, 5, which is 4, 6, and 25. If you add that up, 35. So we're going to have 0.35 for the first entry. All right. For the second entry, we have 9 plus 35, which is 44. Alrighty, and finally we're going to do this last one. So we get 10 plus 3 plus 25. 35, 38. Oh, seems like I must have added up wrong. 4, 6, 25. Oh, oops. I did this guy wrong, right? 6 plus 21 is 27. There we go. Is that right? Yes. Okay. So don't do it by hand. This is the one case where you should be using a calculator. Okay. So what does this vector tell us? Well, it says if we start at time 0, we're going to start in this first state. Okay. One step later, there's a 20% chance we're in state 1, a 30% chance we're in state 2, and a 50% chance we're in state 3. In the next time step, at time step 2, there's a 35% chance of being in state 1, a 27% chance of being state 2, and finally a 38% chance of being in state 3. Now, we can keep applying this equation, and we can say, well, what's the distribution of where we might be located in time step 2, right? Or time step 3. This keeps going and going and going. In fact, what we end up with is a more general equation than just these first 2 steps. In fact, if we want to know where we are at time step n plus 1, we just have to multiply P transpose times where we are at time step n. And again, these u's, these vectors, are going to be a distribution, right? So it's the probability of being in any particular state at time step n. So let's look at this, right? So here you'll notice all these values add up to 1, right? 1 plus 0 plus 0 is 1. Here we have 0.2 plus 0.3 plus 0.5 is equal to 1. And in fact, if you look at the u of 2 case, let's see if I can, I think it's 0.35, 0.38, and 0.2. Ooh, I think I might have forgotten this. That's 7. What we see is, again, if we add these all up, they should add up to 1. Okay, so go ahead and stick this in your calculator. We should get something. Let's just do it quickly. 0.35, 0.27, 0.38. So we add this stuff up, adds up to 0, carry the 2, and then we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1.0. So there we see that this u, okay, this u vector actually ends up being a distribution of where we are at any time step. Okay. So that's a very important point to make.